All right, we are going to start section 4.2, talking about the unit circle. And if you haven't watched the live lesson, make sure you do that from last week. That way you can kind of see the radians versus degrees, but we're going to use the unit circle here. So you're also supposed to look at the video on Edpuzzle, and that's the one that was talking about kind of how we came about to find these spots on the unit circle. And so where those come from. So here's what this is. This is what you've already seen. You've seen this before last year, but again, you hopefully have saw where you can find these coordinates based upon that video that you watch. And there's a lot of symmetry about the unit circle, so you can kind of see that if I take this, here's my y-axis, if I reflect this over my y-axis, it's the same exact coordinates over here, except we're in a different quadrant. So in the second quadrant over here, you see that your x values are negative and your y values are positive. But notice all the ones that are right about here, so the same distance from if this is my x-axis, the same distance from here to here, they all share the same coordinates, except different quadrants are going to have the negatives. Notice that the ones over this way, the ones that are a little bit closer to my y-axis here, these have the 1/2 and the radical 3/2. And so these ones over there, again, the signs are just different. Notice that the third quadrant, you have the x values and the y values that are negative. Over here in the fourth quadrant, the x values are all positive, the y values are all negative. So that's where that's kind of coming from. And so we're going to use this to be able to find certain things on the unit circle specifically. So this is something you want to write down. You can pause the video and write these down. But every time you see a sign, that's just the y value. So it's just the y value of that. Cosine, that's the x value. Tangent, that's the y over the x, assuming that x is not equal to 0. And you can't have answers that say undefined. So if I have 1 over 0, that's undefined. If you have 0 over -1, that's equal to 0. So sometimes with those different values, you may get those answers. Cosecant, secant, and then cotangent. These are just reciprocals. So if I have y over 1 and I flip that, that's 1 over y. X over 1, flip it, it's 1 over x. Y over x, flip it, it's x over y. So whenever I kind of write these, I write them underneath each other, right next to each other, just because we know that they are reciprocal pairs. And we will talk about that in chapter 5 about how we call them reciprocals, and we'll use those for different things. But that's something to want to be able to refer back to. Okay, so let's do an example. So it says the sine of 120 degrees. So first, you got to find 120 degrees. So look on your circle, you can kind of see that kind of on the inner part here, you see the degrees, and a little more of the outer part, you see the radian. So 120, there's 120. So I want to find here, I need to look at these coordinates. Now, that's not my answer. This is dealing with sine. Sine deals with y. So I want to say, what's the y value here? X, y. The y value would be radical 3/2. So that's just simply my answer. So in this case, I'm just going to kind of say that this is equal to radical 3/2. So some of them can be very quick. Others are going to take a little bit more time. Just depends. Okay, tangent. We learned over here, tangent is y over x. So when I do this one, I know I'm going to have to take whatever it is. I'm going to take the y value over the x value. And anytime you're doing fractions, you've got a fraction here, you've got fractions over here. This is going to require a little bit of simplifying. So first thing, I need to find 3π/4. So I'm looking at my outer circle. That would be right about here. And so I get this coordinate point. So we're looking at this coordinate point. So this is negative radical 2/2 and a positive radical 2/2. So I need to kind of take that and simplify it a little bit. So the y value comes first. So that's going to be that radical 2/2. And then divided by, and then you have the x coordinate. The x coordinate is a negative radical 2/2. So then now I need to simplify this. Now, anytime you have a fraction divided by a fraction, we always say it's the top times the reciprocal of the bottom. So this will stay the same. This division turns to multiplication, and then we do the reciprocal or flip the bottom. I have heard people call it keep it, change it, flip it. So keep the top, change the division and multiplication, and then flip it. And so we kind of go along with that thing. Just like we're talking here, the top stays the same. So radical 2/2. Then that changes to multiplication. And then the other one, we flip it. So it'll have a negative, and then it doesn't matter where that negative is, and then 2 over radical 2. So at this point, hopefully something's going to cancel out, but that doesn't necessarily happen. But here it does. I've got a radical 2 on top. I've got a radical 2 on bottom. That simplifies. Same thing here. I've got a 2 on top, and I've got a 2 on bottom. I'm left with a negative sign. So in this case, I know I'm going to be left with something negative. So what it is just dependent upon what it is. Well, if I did 2 divided by 2, that leaves you 1. So if everything cancels out, it's just going to leave you 1. So in this case, my answer is just simply going to be negative 1. All right, cosecant of 11 pi over 6. So I need to go to here, 11 pi over 6. I'm going to find 11 pi over 6. I find it over here. So these are the coordinates that I need. I need that radical 3 over 2 and that negative 1/2. Now cosecant, going back to this, I've got cosecant, it's 1 over the y value. So in this case, I know when I simplify it, I'm going to have 1 over the y value. So I need to find out what that y value is. So again, going over here to 11 pi over 6, there's the y value. It's negative 1/2. So in this case, it's going to be 1 over and then negative 1/2. So I've got that. Now, again, it's another keep it, change it, flip it situation. The top stays the same, so the 1 stays the same. So keep it. This division sign turns to multiplication, and then I have to flip this one. So in this case, it's going to be a negative, and then that 1 over 2 will flip to be 2 over 1. So I get 1 times negative 2 over 1. Well, 1 times negative 2 over 1 is just negative 2 over 1, which is just simply negative 2. That's your answer. Cosine of 180 degrees. So if I got cosine 180, here's 180. Cosine we know is the x value. So the x value at negative 1 or at 180 degrees is just simply negative 1. So again, all I'm doing is I'm going to the angle in question. I find it here. I look at the coordinates. At this point, cosine, as we learned up here, is just the x coordinate of that. So I go to the x coordinate. That's just negative 1. I'm finished. Some of them, as you can see, is 1 over y, for example. In those cases, you have to do a little bit of simplifying. So you have to kind of be careful. Some of them are quick. Some people have the misconception, oh, I find the angle and I just write the coordinate point. No, we actually look at, okay, well, that's the x value and then that's the y value, and then you have to do something with them depending upon which trig function you're dealing with. That's where these guys are coming from. Okay, so what happens if an angle isn't on the unit circle? We're going to find something that is on the unit circle. So in this case, I need to kind of take my values and depending upon what they have. So for example, even if I don't have negative 135, I can still do something to get to that point. So what I can do is I can basically do what we did with my live lesson, and that was with coterminal angles. So in this case, what I can do is I know that if I have a negative and I want a positive, because notice that anything on these unit circle, we have positive values. So I need to get back to something positive, which is why we kind of practice that. So what I need to do is I need to say, okay, well, negative 135, that's not exactly what I want, but I know if I take that negative 135 and I add 360, I'll get and go around the unit circle once and come back to it. So if I simply do that, I get 225. So what this means is that this is the exact same thing. Since they share the same terminal side at 225, which is down here, it doesn't matter how many times you go around, it's still going to end at the same terminal side. Now, if it ends at the same terminal side, it's going to share the exact same coordinate points. So that means that the sign of negative 135 is the same as the sign of 225. So it's the same thing there. So now that I know that, I can go to the unit circle. So if it's not in the unit circle, you need to find something it is. So like we talked about with coterminal angles, that might mean adding 360 or subtracting 360. You might have to do it a couple of times. It might mean adding 2 pi or subtracting 2 pi if it's in radian measurement. So in this case, there's 225. I look at my coordinate points. The sign is talking about the y value here. So I want the y value of that. Well, if I look, here's the y value at 225. It's negative radical 2 over 2. All right, so the secant of 7 pi over 3, secant of 7 pi over 3. So in this situation with the secant here, look for 7 pi over 3. Okay, don't have 7 pi over 3. Remember, this goes around to about 2 pi, so that's a little bit more. If you do 7 divided by 3, it's going to be more than 2 pi. So that's not on the unit circle. So I need to find something that is. So I need to do a little bit of math here. Okay, I'll give myself a little bit of space. So 7 pi over 3. So in this case, that's too big. So that's bigger than this unit circle. And I noticed the last one was too small because it was in the negative, so I added. But 7 pi over 3 is too big. It's bigger than that 2 pi. It's gone all the way around the circle and kept on going. So I'm going to have to go the opposite. So I want to subtract 2 pi to get something that's a little bit smaller. Now remember that 2 pi is over 1, so I don't have any common denominator here. So in order to get that, I want this to be a 3. So I'm going to have to multiply the top and the bottom by 3 to give me something that I need. So then that would give you 7 pi over 3. And then over here, that would give you minus, and then 6 pi over 3. Because I'm doing 2 pi times 3, which is 6 pi, and on the bottom 1 times 3, which is 3. So again, it looks like a 6 pi. Doesn't look very good there. So then now when I simplify this, I know I'm going to have that 3 in the bottom. 7 pi minus 6 pi is 1 pi, or just pi over 3. So that means that 7 pi over 3 and pi over 3, those are coterminal. So then that means that the secant of 7 pi over 3 would equal the secant of pi over 3. And so that's what I'm going to kind of be able to try to do here. So one thing I'm going to try to do is I'm going to try to do a little bit more. Give myself some space here. So secant, going back to here, secant of anything is 1 over the x coordinate. 1 over the x coordinate. So then I need, in order to do this one, I'm going to have to find that out. So I need to say, well, that's 1 over the x value. So 1 over the x coordinate. So at pi over 3, there's my pi over 3. The x coordinate in this case is 1/2. So I'm left with 1 over 1/2. So again, this is another, something divided by a fraction. Keep it, change it, flip it. Top times the reciprocal of the bottom. So the top stays the same. That's 1 times, that changes to times. 1 over 2 flips to be 2 over 1. And if I do 1 times 2 over 1, that's just 2 over 1. And 2 over 1 is simply just 2. All right. Cotangent of 900, cotangent of 900. So 900 is way too big. This is 360. So again, I need to do a little bit of work here. So if I do 900 and I minus 360, I'll take 900 minus 360, that'll give me 540. So 540 is still not there. So I'm going to do it again. Subtract 360. So you take 540, you minus it from 360, and this time you get 180. So that means that 900 and 180 are coterminal. Now, if they're coterminal, they'll end on the same terminal side, which means they'll share the exact same coordinate points. So the cotangent of 900 is the same thing as the cotangent of 180. So at this point, I need to say, okay, well, cotangent, that's my x over my y. So cotangent is my x coordinate over my y coordinate. So I need to say, okay, well, go over here. So in this case, my x coordinate's -1, so that goes on top, over my y coordinate, that's 0. Well, anytime you divide by 0, that's what we call the undefined. That's undefined. If it was 0 over -1, 0 on the top's okay. Anytime on the top is equal to 0, then it's going to equal 0. But if the bottom equals 0, that's undefined. Okay. Cosine of -pi over 4. Cosine of -pi over 4. So in this situation, we don't have -pi over 4, so we need to do a little bit of work. So I take that -pi over 4. That's too small, so I'm going to add 2 pi. That's 2 pi over 1. I don't have a common denominator. I can multiply both top and bottom by 4. So that would give you -pi over 4 plus, and then 8 pi over 4. So 2 pi times 4 is 8 pi. 1 times that, and we can say, hey, 8 divided by 4, that's 2 pi. That's equivalent. So my denominator is 4. Negative, remember, that's really a negative 1 pi. So negative 1 plus 8, that's 7. So then this ends up giving me 7 pi over 4. And 7 pi over 4, I do have on my unit circle. So then that means that the cosine of negative pi over 4 is the exact same thing as the cosine of any coterminal language. In this case is 7 pi over 4. So remember, cosine, that's just dealing with my x value based upon those things you wrote down. So if I go over here to 7 pi over 4, the x value is just radical 2 over 2.